Rescue is nearby. Why do large earthquakes result in heavy death toll? Dozens of earthquakes of middle intensity, within range of 5 and 6 by Richter scale, and several destructive earthquakes with intensity of more than 7.5, causing death of several thousands of people, take place annually. Thus, the Mexico earthquake, with force of 8.1 by Richter scale, razed the city to the ground. At that, more than 20,000 of people died, 40,000 people were injured, 31,000 people were left without shelter. What does cause the earth shaking? There are fractures in the earth. Big blocks of lithosphere of the earth periodically shift over these fractures. These shifts bring to abrupt movements of the earth's layers relatively to each other, thus generating seismic waves. Seismic waves shake the earth. How may one save his life during strong earthquake? The only way is to construct seismic-resistant buildings. Why is this not applied all over the world? The answer is trivially simple. Seismic-resistant buildings, comparing with non-seismic-resistant buildings, are very costly, higher by tens and 100 times. Neither majority of people nor big countries can afford acquiring such non-seismic-resistant buildings. Is it possible to decrease the cost of seismic-resistant constructions, taking into account that in many densely populated countries located in seismic-active regions, majority of population lives in small, private 1-2-story buildings? They get destructed even at earthquake of 6. The point is, even buildings constructed by frame house technique are non-seismic resistant ones. Look at the results of bench tests conducted by Japanese scientists. Mechanical connection of brickwork with concrete framework is weak, and eventually it is destructed our first shocks of earthquakes with force of 6.57. What is an ideology of seismic resistant construction? There are several main ways to construct seismic resistant buildings. For example, flexibility of blocks between floors of buildings is to be the main issue. Rather expensive and complex systems of connection between blocks are applied, which enable building to bend and to move at zones of joints of floors, but for all that not to be destroyed. For example, systems of seismic isolation are much diversified. Seismic isolation, though, isolates the upper part of buildings from surface of the earth during earthquakes. Foundation of buildings executed as peculiar sliding and shaking supports. Thus, foundation of building starts moving with oscillatory movements, whereas the building itself, as a result of inertia, as if slides over foundation. Another system of seismic protection is based on application of the so-called shock absorbers. These are special devices located on roof or upper floor of building with system of flywheels or counterbalances, which start generating oscillations similar to seismic ones but in antiphase. Thus, they as if compensate seismic fluctuations and do not allow building shaking and destructing. The most seismic resistant modern buildings are constructed with application of complete steel constructions and floors made from light synthetic multi-layered planes. All this costs much. The Scientific Research Institute on Prediction and Study of Earthquakes of International Academy of Sciences selected basically new way. Under leadership of the director of the institute, the vice president of the Eastern European section of International Academy of Sciences, Doctor of Geology and Mineralogy Sciences, Professor Elchin Khalilov, it became possible making seismic-resistant construction of new generation, but first of all, buildings which are not expensive one and affordable by majority of people of modest means. Building constructed by new technology is also able to bend and to change shape at large earthquakes, but it significantly differs from existing seismic-resistant structures. The floors themselves in other types of seismic resistant constructions are rigid and joints between them are flexible. Each point of the building in new construction is a joint of bending or a joint of shift. Speaking simply, building made of seismic resistant blocks may be subjected in any point of bending and to change its shape, but nevertheless it does not crash. At the same time, after passage of seismic wave, building restores its initial shape. How does this take place? Let us cite an example. The principle of new technology of seismic resistant building is similar to this. Blocks are connected between each other by means of geometric elements. Convex parts of blocks are inserted into special grooves like Lego constructor. But it is impossible constructing seismic resistant building based on Lego, because Lego constructions are rigid ones. Calculations are rechecked experimentally. By changing angles or ratio of elements, nothing will happen. Blocks will stop functioning. Damping substance. Professor Khalilov's know-how is applied at joints of blocks. This substance prevents blocks from destroying at big acceleration of shift and plays a role of shock absorber. Thanks to this, the building retrieves to its initial position. Each joining of seismic resistant blocks is a hinge. Thus, the whole building consists of solid hinges, preventing its destruction. The most important property of interconnection of seismic blocks is possibility of its restricted movement and turning relatively to each other in all planes. Blocks are also able moving with elastic oscillation movements in horizontal plane. With aim to study effectiveness of seismic resistant blocks in practice, special seismic test bench imitating oscillations of ground at large earthquakes was established. What does this device represent? It is a rigid platform where vibrating platform is installed on special springs. The vibrating platform is set to motion by means of special vibrator. Three-component seismic sensor connected with digital seismic station is installed on vibrating platform. Subsequent analysis of records of seismic station allows with big accuracy controlling and studying accelerations and intensity of imitating earthquake. Let us compare behavior of buildings made from seismic resistant construction blocks and behavior of common construction brick limestone by means of simultaneous tests. The building to the right, made from common construction stone, was destroyed after 5 seconds, and building to the left, made from seismic resistant blocks, was not destroyed even after half minute of intensive oscillations. But how will blocks of natural size behave? As everyone knows, it is impossible to take into account all technical nuances during construction of a model. Vertical steel pins are rigidly fastened to vibrating platform, imitating surface of the earth. These pins traverse holes to seismic blocks with height of 3 rows of bricklaying. The same fastening is envisaged at construction of buildings. Experiment has proceed further, situation becomes strained. If at every amplitude of oscillation one increases time of influence, then intensity of earthquake will continue increasing. Intensity increases up to 10-12. However, the wall continues swaying as if nothing happened. Simply, earthquakes lasting for 25-30 minutes are not observed in nature. Tests surpassed all expectations. Then conditions of experiment get more strict. Amplitude of oscillations increases, the force of earthquake reaches intensity of 7.5 and 8. As it is seen, amplitude of oscillations of walls is rather high. Thus we see the wall made of common construction stone does not stand. It breaks horizontally almost in the middle. Broken piece of the wall falls on the second wall, made of seismic resistant blocks. The hearts of developers sink. Will collapsed wall crush seismic resistant wall? Seismic resistant wall remained safe in spite of blow, and that piece of broken wall presses it. Experimenters decide to follow out. At last, culmination point comes. Broken piece and balanced part of the wall, made of common blocks, get destroyed immediately at several places. At that, the part of broken wall falls once more on seismic resistant wall. Let us see this process in delayed action. One may observe the blow is very strong. All persons are sure. Hence, seismic resistant wall will not stand additional mechanical blow. However, it stands in contrary to all expectations. This is really great success of the author and the team of developers of seismic resistant construction blocks. Why doesn't building collapse? Even if the building does not collapse, what does make it stand? The point is the peculiarity exists in fastening of the building itself to foundation. Steel pins are walled along the perimeter in concrete foundation of a building, firmly set on the earth's surface with application of steel piles. The first 3-5 rows of seismic resistant construction blocks are put on these steel pins, depending on height of the building. Steel pins provide flexibility of cohesion between lower part of the building and static foundation. Thus, connection with concrete blocks between floors is established. Steel pins are walled into concrete floors by perimeter and enter by lower part into holes of seismic blocks of lower floor and by upper part into holes of seismic blocks of upper floor. Thanks to this, flexible and solid connection between floors and concrete coverings is established. By the way, construction of buildings does not exclude possibility of additional application of technology of seismic isolation. Both seismic resistant skyscrapers up to 10 floors and low buildings, particularly cottages, villas, private houses, summer cottages, may be constructed on basis of seismic resistant construction blocks. The author and developers guarantee seismic stability of buildings made of seismic blocks at earthquakes up to 11 by Richter scale. Cost of seismic resistant buildings made of seismic resistant blocks. Calculations made in Scientific Research Institute on Prediction and Study of Earthquakes indicated cost of buildings constructed on base of Elchin Khalilov seismic blocks will be in maximum by 10–15% higher than cost of construction of common non-seismic resistant buildings constructed on skeleton basis or from construction brick. Decrease of cost of construction of buildings based on seismic blocks is achieved thanks to exclusion of application of cement solution at erection of wall laying and to simplicity of construction process and relatively low cost of seismic blocks themselves.